These are the two equations that define the equilibrium in the market. The first one is a relationship between prices and number of firms. The price is inversely related to number of firms. As number of firms increase in the market, there will be more competition in the market, which would drive down the prices. The CC function gives you the relationship between the average cost and number of firms. When the number of firms increase, you have a smaller share of the market. Your output decreases. As your output decreases, your average cost will increase. This arises really from economies of scale. Now let's draw these two equations on the same graph, and wherever they intersect, that would give us the market equilibrium. On the x-axis, you measure number of firms, and on the y-axis, you measure average cost and the price. And let's draw the CC function first. This is your intercept constant plus n into f by s, and this is your slope, right? So if you draw this CC function, this is the intercept, which is the marginal cost, and the slope of the function is given by f by s, right? So this is really of the form y is equal to a plus bx, right? Where y is your average cost. Now the PP function, you have the same marginal cost as the intercept, but it's a quadratic relationship, and it's a positive relationship between prices and n. So price is here and n is here, and the PP function has a positive slope, right? So let's superimpose that on this graph, PP function. Now what this tells us is if you have n1 number of firms, the price that you charge is P1. As number of firms increases, the prices fall, and this is really because of increase in competition, right? The average cost function, the CC function, is telling you when the number of firms was n1, the average cost was AC1. When the number of firms increased to n2, the average cost increased to AC2, right? So there's an increase in average cost as number of firms increase. And this is telling you that there are economies of scale. So as number of firms increase, you lose that economies of scale and the average cost increases. So this is what the equilibrium condition looks like. In this case, the equilibrium is at point E, where you have n2 number of firms in the market, and the equilibrium price and average cost is P2 and AC2. What happens when you open up to international trade? The market size increases. So first of all, let's just look at these two equations. Market size increases, which is captured by the variable S. It doesn't show up on the PP graph, PP equation, so nothing changes for this graph. But on the CC graph, you have f that enters as a slope, right? So if you had the two equations, so as S increases, the slope changes, it becomes less. So what you see is that a clockwise movement of the CC function to CC2. But the intercept hasn't changed. That's still marginal cost, C, right? The only thing that has changed is that there has been an increase in S, which changes the slope. Well, what happens to the equilibrium condition in this case? The new equilibrium point is at point 2. There's an increase in number of firms, and there's a decrease in the price of the product being charged. So this is the effect of a large market in the case of monopolistically competitive industry, right? And the next video will discuss the short and long run implications of an increase in market size. What we see here, a move from 1 to 2, is really what's happening in the long run, right? Yeah, that's all for today.